Right. Hello, everyone, and thank you for joining us for week 8 of the Concentrator Talk brought to you by the Oxygen Alliance. My name is Mwai Lungu, and I'm currently joining in from Lilongwe, Malawi. I'm pleased to be hosting the Concentrator Talk today. Joining me are my colleagues, Amaprit Rai. So we also have several technicians on the call with us today to answer the different questions that we've received. So we have Paulina Mohosho joining us from Johannesburg, South Africa. We have Kuwinda Singh joining us from Chandigarh, India. And we also have Georgie Kwanga, Sharon Gozo, and Francis Sambani joining us from Lilongwe, Malawi. So for those of you that may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time to discuss the different aspects of oxygen concentrator assessment, oxygen concentrator use, and maintenance. So remember that you can always send questions to us by email to info@oxygenalliance.org, and we'll do our best to respond to your questions during the next Concentrator Talk. So if you have questions that you would like to ask during the session, you can type them into the chat and we'll do our best to respond to them. So just a reminder to all of us that we ask you to keep your videos turned off and your microphones muted just to conserve bandwidth for everyone. So as usual, we also have a topic of interest today, and we will be talking about negative impacts of dust on oxygen concentrators. So we have also arranged some polls on some of the questions, so please make sure you attend to them when they pop up. So I'll read out each question and ask one of our technicians to respond. And we'll also paste the questions in the chat so that in case you missed it, you'll also be able to read it from the chat. So moving on to the questions now. So our first question says, during a planned preventative maintenance that I was carrying out this week, I came across an oxygen concentrator that had a power failure problem. This concentrator had both the power failure alarm and power failure LED, but both the LED and alarm could not be activated before and after rectifying the fault, even if the unit was disconnected from power. So what could be the cause of the alarm and how can I fix this problem? So I will ask George to take this one up.
Thank you, Maui. For the alarms and the LEDs to work in an oxygen concentrator, there's a need for power source and a signal from the control board. Most oxygen concentrators are fitted with a 9-volt battery that acts as a power source to the alarms and the LEDs when the mains electricity goes out. When the battery drains or is disconnected from the circuit, the LEDs and the alarm will not be receiving the required voltage. Hence, they will not work. If you find yourself in the situation where the power failure alarm and the LEDs are not working, you should do the following. Firstly, you need to check the battery voltage and replace it if it has low voltage. The second thing that you're supposed to do is to check the electrical connections. That is if the battery voltage is okay. The third thing that you're supposed to do is to check continuity of the cables joining the battery to the control board. So you need to replace the cables if there is a disconnection. So in other models, you will not find the battery. They are fitted with a capacitor on the control circuit board instead of that battery. So the capacitor gets charged when the concentrator is running. So sometimes when you can have a situation where it's discharged. So this can result maybe if the concentrator hasn't been running for an extended period. So if you have a power failure alarm or LED does not get activated when the concentrator is disconnected from the mains and the switch on the concentrator is on position, you need to do the following. First, you need to run the concentrator for some minutes to charge the capacitor. Then test the capacitor by disconnecting the mains. That is, you need to learn for some time, and then you turn it off, disconnect from the main power source, and turn the on switch button so that you test the capacitor if it's working. The second thing that you're supposed to do is to check if the capacitor is bent. Sometimes the capacitor can get bent, so you need to check that. Other thing you need to do is to measure the capacitors using a capacitors meter. So what you have to get is a rated value for that capacitor. So you replace the capacitor if you find it is 40. So in case if the capacitor is in good condition, check the capacitor circuit. And there may be a need for resoldering if there are loose connection in the capacitor circuit. The problem may also arise when the buzzer and the LEDs are 40 or they're disconnected from the circuit. So what you need to do is to supply the required voltage directly to the buzzer and the LED. They have to be activated. If they are not, they are 40 and you need to replace them. If they're activated, then the problem can be with their connection. Check it and correct any disconnection identified. The activation of the power failure alarm also requires the switch to be in on position. Thus, the alarm will not work if the switch is 40. So you try to replace the switch. If you replace the switch and the alarm get activated, then you know the problem was with the switch. So as you can see in the graphics there, that's an example of that's a battery, and the other one is also indicating what thing is that's a buzzer. Thank you so much.
Thank you very much, George, for that explanation. So if we have any questions from the audience on the explanation that George just gave us, please raise your hands and he'll answer your questions. If we also have some further comments from the other technicians, please, you can also come in and add on to that explanation. If we don't have any questions, I'll ask Amapri to please open our first poll of the day.
Thanks, Maui. Our first poll is, have you ever changed the battery for an oxygen concentrator? Maui, do you want to just remind everyone how to get to the polls as well?
Yeah, sure. So for those of you that are connected via your laptops, if you go to the bottom right of your screen, you will see there is an activities menu button. So if you click on that, it activates a window which has pause as one of the options. If you are using your mobile phone, then just go to the bottom right of your screen again. You hit the options menu, and that will bring up a window with a number of icons, and the activities menu is one of those icons. So if you click on there, you should be able to see the pause option from there.
Thanks, Maui. And it seems like most people have changed a battery for an oxygen concentrator before.
Great. All right, so moving on to our next question now. So for this question, we actually received two similar questions. So I'll read them both. So Francis also just pasted both of the questions in the chat, but then the answer is similar. So please pay attention. So the first questions that we received says, I have an oxygen concentrator and the compressor has blown out windings and its maximum pressure rating is 87 psi. In the workshop, we have another oxygen concentrator with a bent control board, but its compressor is working fine and is rated at 76 psi as its maximum pressure. The two compressors have the same dimensions and positions of intake and exhaust ports. Is it possible to swap the two compressors? So that's the first question that we got. The second question says, I am a biomedical technician of a certain district hospital. I have a concentrator which was producing a loud noise from the compressor. I am also getting low flow, low pressure, and low purity on this concentrator. I have 2 spare compressors of the same model from my oxygen concentrator graveyard, which I would like to replace the worn-out compressor with. Would you advise me on a test I would carry out to know which of these 2 compressors is in better condition? So I'll ask Paulina to please answer these 2 questions.
Okay, thank you, Mwabi, for the question. Okay, so every compressor model has a performance chart that is provided by the manufacturer. The performance chart will shows the performance of the compressor under different voltage ratings as provided by the local electricity suppliers. It would either be a 220 volt to 230, or it could be 115 to 120 volts. The 2 parameters are considered in terms of performance of a compressor: pressure and the flow rate. So a compressor will have specific flows. It is supposed to reach at specific pressures when it is in a good working condition. So as time goes by, the piston caps, the sleeves, gaskets, and O-rings wear out. As they wear out, the compressor will not be able to reach the initial flows at the specified pressure values as given by the manufacturer. This then will be an indication that a compressor is underperforming and needs to be serviced by replacing the caps, sleeves, gaskets, or O-rings. So for you to accurately measure the flow at the specified pressure, you would need a way of controlling the output pressure of the compressor and measuring flow readings at those specific pressures. Flow readings can reach over 100 liters per minute. As such, this is not possible to be carried out with readily available tools or equipment. So one's approach you would use in your case is that of a maximum pressure and a maximum flow. As the compressor overhaul kit wears out, the compressor will not be able to achieve the maximum flow and the maximum pressure reading as given by the manufacturer. The ZW280 compressor has a maximum flow of 94 liters per minute and a maximum pressure of 73 psi. As already said, it will be challenging to measure the maximum flow rate at 0 psi. As such, you should measure the maximum pressure on the 2 compressors. So for you to measure the maximum pressure, you connect the pressure gauge to the exhaust of the compressor and block any other exhaust airways, including the pressure relief valve. Measure and record the maximum pressure that you will get from both of your compressors, the spare compressors that you have, and then you can just compare the readings that you get with the maximum pressure given by the manufacturer. So once you have your reading, the reading that is closer, that has a value that is closer to the maximum pressure given by the manufacturer, is a compressor that is in a better condition. So you can use that compressor for a repair. Thank you, Mwabi.
Thank you very much, Paulina, for that explanation. So if we have any questions or comments on the explanation that she just gave, please raise your hand and then you can ask the question. All right, seems we don't have any questions on that. So we also have another poll on this question. So Amapri, if you would please launch the poll.
Yes. Our next poll question is, have you ever replaced a compressor?
So just a reminder to those of you that are joining us for the first time, if you want us to add you to our mailing list so that we can be sending you reminders and updates from the Oxygen Alliance, please paste your email in the chat, and Also just indicate where you're joining from so that we can add you to our mailing list.
All right, it seems like most people have replaced a compressor. We have a lot of votes for yes on this one.
Great, thank you very much. All right, so moving on to our third question of the day. So it says, I am a nurse at a public hospital. I have a new patient that requires oxygen therapy, but we have run out of distilled water that we use to fill the humidifier bottles. Can I use tap water in the meantime? I'll ask Paulina again to take this one up.
Thank you, Mobi, for the question. Okay, so the humidifier bottle at the outlet of the oxygen concentrator helps to moisten the air so that the patient does not receive dry air that can cause the airways to dry up. Since the air from the humidifier bottle goes directly into the patient's airways, it is advisable to use distilled water. Distilled water is water that has been boiled into vapor and condensed back into liquid to separate it from impurities that do not boil below or near the boiling point of water. It does not contain bacteria and salt. This is ideal for infections and preventing infections. If distilled water is not available, distilled water can easily be produced by distillation. So you would require a large pot with a lid, a small pot without a lid, and ice. First, place the large pot over a stove top burner and add water. Then place the smaller pot inside the large pot. At this point, the smaller pot should float on top of the water. The key to circulating water vapor inside the large pot is airflow. Make sure the smaller pot has plenty of it, both around its sides and between it and top of the larger pot. Next, turn the burner to 100 degrees to 212 degrees, which is the boiling point of water at sea level. This will facilitate the conversion of liquid water to vapor. After you put the burner on, place the lid upside down on the large pot. Lids are usually higher in the middle than around the edges. Flipping the lid will allow the condensed distilled water to trickle down to the middle of the lid and into the smaller pot. Once all this is done, head over to your ice maker or a tray and load the top of the inverted lid with ice. The difference in temperature on both sides of the lids will speed up the condensation process. After this process, the bacteria will be removed because of the heat, and the salts will remain as solid residues at the bottom of the large pot. Wait for the distilled water in the small pot to cool down, and then place it in the humidifier bottle. Thank you, Mobi.
Thank you very much, Paulina, for that explanation. So if we have any questions on that, please raise your hand or you can just type it in the chats. Yes, Noel.
Yes, I think what Paulina has explained is in right order, but according to Malawian setup, it's very, very difficult to have such a procedure because these things happen when there is always a need that the people are already stuck. So for me, usually I do not recommend using humidifier bottles because of the carelessness that happens, because it becomes a bacterial habitat. So I would recommend in that case that there's no distilled water available. I would recommend to use the same tap water, but has to change, not be more than 2 hours, as we're waiting for the process that my colleague has already explained. But otherwise, I would say maybe you should just go without humidifier bottles, because normally there is too much carelessness when it comes to handling of humidifier bottles. So they need to be very much skeptical on how these things, on how a patient should be handled. I think that's my comment.
All right, thank you very much, Noel. Amapri, I see you also have the hands.
Yes, thank you, Noel, very much for your comment. What I wanted to do is share kind of what the point of humidification is. It's really about patient comfort. So oxygen is a very dry and very cold gas. So particularly at higher flows, if you're not using a humidifier, the patient's nasal passageways or their upper airways can dry out, and that can be very painful. And that can result in patients not wanting to stay on oxygen therapy even if they need it. For patients that are, more critical, that need to be on oxygen for extended period of time, like 24 hours in the hospital, if it's not being mixed with other gases, like you're using it just from a concentrator, that can cause a lot of discomfort. And in those cases, typically the physician would recommend using a humidifier bottle. Obviously, it's resource dependent. If you don't have water, it cannot be changed regularly. I would say that if you have the option and the resources are limited, for patients that are on higher flows, it is more important to use a humidifier bottle. It can also depend a little bit on how humid the air is around you. So like less of a requirement during higher humidity times of the year. And you should also just try and make sure that when you are using humidifier bottles, that it is being changed out regularly, or you are distilling the water as best as possible. And we can discuss this more in a future call if there is more questions around humidification and the importance of it.
All right, thank you very much, Amapri, for that. I don't know if we have any further comments on that, but we also have another poll here. So Amapri, maybe if you just launch that one.
The poll I have is not for this question.
Oh, sorry. Yeah, I missed that. Thanks. All right, so moving on to our next question. So the next question says, I am working on a Devilbis 525 concentrator that was overheating after 20 minutes. During the maintenance process, I noticed that the fan was faulty. I replaced the fan with a new one, but the concentrator is still overheating. What could be the cause and solution to this problem? I'll ask Georgie Kwanga to take this one up, please.
Thank you, Maui. Every concentrator has a fan, and in some other models, you have two fans, and usually the fan is located next to the compressor. A compressor by design produces some heat, so the fan helps to cool it down to ensure that the recommended working temperature range is maintained in the concentrator. The recommended working temperature range varies with the brand and the model of the compressor. So for example, for Devilbis 525 compressors, the temperature range is between 5 degrees Celsius to 40 degrees Celsius. So when the fan is 40, the compressor overheats, just like it did in your case. And eventually, the compressor shuts down. This is mainly because every compressor has a thermal switch that switches off the compressor once a particular threshold temperature is reached. In this case, above 40 degrees Celsius. To fix the 40 fan, one needs to replace it with a new fan. When replacing, you have to take note of some fans are the AC and others are DC, rated voltage. So you need to pay attention to that. Another thing you have to take into consideration is the power rating of the fan. So interchanging these can end up damaging the fan, even if it's brand new. So apart from the voltage and the power rating, you also have to take note of the orientation of the fan. by checking the two arrows. As you can see there in the graphics, there are two arrows. One indicate airflow direction, and the other one is indicating the blade rotation direction. So you have to consider that. The placement of the fan in the concentrator affects whether it blows cold air into the concentrator from the external surrounding, or it sucks hot air from the concentrator to the external surrounding. So the way the fan is placed varies in different concentrator plans. For the developed plans 525, 515, the fan is placed in such a way that it sucks the hot air from the concentrator to the external surrounding. When the orientation is reversed, it blows air from the external surrounding into the concentrator, and this slows down air circulation, which leads to overheating, basically after a particular period of time. Thank you so much.
Thank you very much, George, for that explanation. If we have any questions or comments on the explanation that George just gave, please raise your hand and then we can address it. Yes, I see we have a hand from Bikash.
My name is Bikas, and I'm a president of Biomedical Engineering Foundation Nepal. So I'm attending for the first time here in this Oxygen Alliance talk, and we have our two team members here. One is a biomedical engineer, Ms. Anju Srestha, and one is an oxygen technician, Mr. Prakash Adhikari also. So my question is that, so we have got many oxygen concentrators from many organizations, from different donors organizations. So we have installed, and we have been doing a lot of installation in oxygen concentrated as well as oxygen plants. So main concern in Nepal is that, so we have got enough oxygen concentrators and as well as oxygen PSA oxygen plants. So main concern is that, so we have to manage how we are going to maintain repair and maintenance, and as well as preventive maintenance for these oxygen concentrators and oxygen plants in around Nepal. So we have some difficult geographical conditions, like we have in plain terrain region, and we have some hilly region also. So we don't get frequent oxygen spare parts like in the oxygen concentrators and as well as oxygen plants. So my main question is that, so how can we manage these spare parts for the repair and maintenance, and how we can plan these preventive maintenance as well as some corrective maintenance for oxygen concentrators and as well as oxygen plants.
All right, thank you very much.
Yeah, thanks, Bikash, for your question here. What we'd like to do, and welcome to the Concentrator Talk, we would be very happy to work with you in figuring out what type of preventive maintenance that the concentrators that you're working on is. If you can give us a list of what you're seeing in Nepal right now, which are the brands of concentrators that have been donated, we can develop a plan, and then we can share that on a future Concentrator Talk and work with your team to get that fully set up so that you're able to implement it. And that can include the spare parts that you're looking for as well. So if you can give us a little bit more information, you know, how many sites or what types of concentrators you're seeing or the quantities of them, we can help develop a plan for you. All right, Maui, do you want to continue onwards? I think we have a poll.
Yeah, sure. I think you can launch that one up now.
Thank you very much for.
So our yeah, sorry, Bikash, were you saying something?
Yeah, thank you very much, Amapit, for organizing this very wonderful talk, and we will provide you all the specs and what we have received so far, and we'll need some feedback from you. So we'll provide you all the specifications and some plans and concentrators from in next meeting. Thank you very much.
Great. Feel free to email us across that information. So our
sure.
poll question here is, have you ever changed the fan? And so far it is looking like very 50-50 on who's changed a fan and who hasn't.
All right, great. So moving on with our questions now. So the next question says, I have an oxygen concentrator that has a problem of low oxygen. I refilled the sieve beds and serviced the compressor just like in your video. Upon replacing the compressor back, I noticed that the sound has changed and it is noisy. What might have caused this and how do I resolve it? So I'll ask Sharon to take this one up. And Amapri, if you maybe could please paste the link for this compressor servicing from our YouTube channel, that would be helpful.
I will.
Sharon.
Thank you, Mari. Okay, so a compressor is one of the many parts of a concentrator. It sucks ambient air from the surrounding and compresses it into the sieve beds. When the compressor runs for a longer time, its caps and sleeves get worn out and its performance decreases. In order to restore its performance, it needs to be serviced by replacing the caps and sleeves. So one thing to note when servicing a compressor is to make sure the screws are tight enough when you're assembling it. Make sure every part is assembled correctly. If you can't remember how to reassemble it, you can mark the parts, take photos, or even record a video when unscrewing the compressor so that you can remember easily. You also have to make sure that every screw is tightened. If the screws aren't tight enough, the sound of the compressor can change and can even affect the performance of the compressor. So in your scenario, you have to unscrew the compressor. Make sure that the cap and the cap retainers fit properly, as this may affect the performance of the compressor if they don't fit properly, and screw the compressor back again. This time around, make sure the screws are tight enough. Thank you.
Thank you very much, Sharon, for that explanation. So if we have any further questions or comments on the explanation that Sharon just gave, please raise your hands and she will address it. We have a hand from Noel. Go ahead, please. Noel, I think you...
Okay,
Yeah.
Thank you so much, Sharon. I encountered a similar problem whereby I had to change the sieves and the caps of the compressor. It was noisy at first, but after changing the caps and the sieves, it was more noisy than before. So I tried to do whatever you have explained here, but still more, I did not solve the problem. So I just, I'm still keeping the concentrator. I'm still working on it. I have all the things done, the screwing back. I think everything is intact, but it's still more noisy. I don't know what's the problem up to now.
So no, Amapri just posted a video from our YouTube channel. So we talk and explain about how to service an air compressor. So maybe you might want to watch that video and see if maybe there was a certain process that you might have missed. So maybe that might help to fix your problem.
Otherwise, we can suggest, Noel, if you want to take some videos or pictures and email those over to us, we can try and take a look as well and see what we can suggest to help you figure out what is still causing the noise. I'll put our email address in the chat again as well.
Yeah. All right, so moving on, we'll take a slight diversion from the questions and we'll jump on to our topic of interest for today. So Francis Sambani will be taking us through the negative impacts of dust on oxygen concentrators. So Francis, you can go ahead, please.
All right, thank you, Maui. So as Maui already pointed out, we'll be looking at the negative impacts of dust on oxygen concentrators. So I will try to break it down into 3 parts. The first part being how dust gets into an oxygen concentrator. Then we'll look at the main topic of today, that is the negative impacts of dust on oxygen concentrators. Then we'll proceed on how we can prevent this dust from getting inside our oxygen concentrators. So compressors are the main reason why how dust gets into an oxygen concentrator. So compressors do suck ambient air into the oxygen concentrator. So when sucking the ambient air and dust, dust and other particulates are sucked into the oxygen concentrator as well. And also, it's worth noting that some areas have more dust compared to other areas. So in those areas that they have like a lot of dust, you're more likely to get a lot of dust into that oxygen concentrators situated in that area. So moving on to the negative impacts of dust on oxygen concentrators, there's several ways how dust does affect an oxygen concentrator. And the first one being that dust can accumulate inside the sieve beds. In that case, it will lower the performance of the zeolite itself. So dusty sieve beds are not as efficient in nitrogen absorption and oxygen purification because the dust takes up some of the surface area that is, for nitrogen absorption. Since the surface area of nitrogen absorption is reduced, not enough oxygen will be produced, thus reducing the period of oxygen being delivered to a patient. So inside the sieve beds, that's one way. And also still on the same, the sieve beds filled at themselves might get dirty with dust. So this restricts the amount of air being delivered to the sieve bed. That's reducing the pressure which build up inside the sieve beds and also the cycle pressure of the oxygen concentrator itself. So this in turn reduces the purity of oxygen being delivered to a patient. So that's one way. And the second is so as I think on the graphics, I think you can differentiate between can you go like up? The one which shows the filters for the sieve beds. Yeah, that one. So yeah, you can differentiate between the two sieve bed filters. So the other one is dirty with dust, and then the other one is clean. So most likely the dirty one will like restrict the airflow going to the sieve bed. Moving on to the second point on how dust can impact an oxygen concentrator is that dust will accumulate on the control board, affecting the oxygen concentrator's performance in 2 ways in this case. So one way being that it causes the components on the control board to retain heat, and also the second being that it can cause a short circuit on the control board itself. So electric components do dissipate heat, and that heat needs to be washed off the surface of those components for optimal performance. So when dust does clog on the surface of this component, they will retain heat. The heat isn't dissipated off. So when the heat isn't dissipated off, they will operate under a higher than normal temperature condition. In this case, the overall performance of the oxygen concentrator is affected, and you're more likely to get low oxygen purity. And also, in terms of a short circuit, dust can clog up ICs on the control board, that is integrated circuits. So a short circuit will only happen if the dust itself does contain like some conductive elements in it, like some conductive material in the dust, because the concentrator doesn't necessarily just suck in dust alone, but it can also suck in other particulates in the surrounding air. So as you can see on the graphics, you have a picture of a dirty control board and also just dirty overall inside the oxygen concentrator itself. So that's the second way how dust does an negative impact, does impact negatively an oxygen concentrator. So the other things that can happen is that you may clog up the cabinet filter if you don't clean it up regularly. So dust will eventually accumulate also inside the tubings of the oxygen concentrator as well, apart from the cabinet filters themselves. So the most affected tubings are those before the sieve beds. That is the ones before the compressor and after the compressor. So if this happens, you restrict the airflow, in turn causing the compressor to overwork. And when the compressor overworks, it will heat up more and in turn reduce the oxygen purity of the air being delivered to a patient. And also, so that's like the third way. And also the fourth way how dust can negatively impact an oxygen concentrator is that dust can also accumulate inside the cylinder sleeves of the compressor. So if dust does accumulate inside the cylinder sleeves, it will increase the friction between the caps and sleeves of the double wobble compressor. So also dust and debris will also raise the internal temperature of the motor and keep it from cooling. So this will only happen if the dust does coat the internal windings of the motor of the compressor itself. So this will also lead to excessive heat over a large period of time. Dust can also clog the exhaust muffler itself, thus making it difficult to completely purge out the nitrogen from the sieve beds. So this will also affect the oxygen purity being delivered to a patient. So those are like the, okay, I think on the graphics we have a picture of an exhaust muffler which is dirty. So in that case, you're not like purging out all the nitrogen from the sieve beds. So those are the ways how dust can negatively impact an oxygen concentrator. And also moving on to how we can prevent dust from getting inside an oxygen concentrator. So customary oxygen concentrators will have a series of air filters. Some of these filters work to clean air before it goes through the compressor, and some clean the air before it is delivered to a patient. So we'll focus more on the filters that prevent dust from going through the compressor. So you have the gross particle filter, which is also referred to as the cabinet filter, and also the intake filter, also known as the HEPA or high efficient particulate air filter. So this, as already said, they help prevent air particulates and bacteria from going through the compressor. So on the graphics, we have these two filters. The first on the left, that's the cabinet filter, and on the right, you have the HEPA filter. So the cabinet filter is typically made up of foam, as you can see, or as you've experienced, and usually it sits on the exterior of the cabinet of the oxygen concentrator, exterior cabinet of the oxygen concentrator, and it is used to stop large items like, let's say, for example, lint or maybe pet hair from getting inside the oxygen concentrator. And these filters are recommended that you rinse them off once every week, or maybe twice, or maybe bi-weekly. Sorry. So you should let them dry before placing them back in the machine. And also, it may happen that in some cases they may be excessively dirty, so you should wash them with warm soapy water and let them dry completely before reinstalling. So that's for the cabinet filter, how you can take care of it. Now for the HEPA filter. The HEPA filter is actually made up of pleated paper material encased inside a plastic housing. These filters are not serviceable, so do not attempt to clean them. Simply throw them away and replace them once a year after use. So the purpose of the HEPA filter is to clean the air before it goes directly to the compressor. As the filter gets dirty, you may observe that the white filter paper inside it starts turning black where the air enters the filter. So this is actually normal and proof that the filter is doing its job. So you shouldn't be worried when you see such a case. And also, I think at this point, it is worth noting that in the developers, that is the 525 and the 1025 models, they stopped using the gross particle filters since October 2020. But then nonetheless, even though they did stop, you can still install a gross particle filter if needs be. Let's say, for example, if you're operating the concentrator in an area which is very dusty, I mean, there'll still be use for that ghost particle filter. So you can still reinstall it on these newer models. There's still space. If you can go down, I think we have another graphics. Yeah, so that is the graphic for the DevOps models. You can see you have the new filter door and you have the old one. The old one, the new one doesn't have like the space, it just has vents. But on the back side, that is the inside of it, you can install the filter if you want to. So that's on the developers. And the last way you can prevent dust is you should make sure that you use your the area where you use your oxygen concentrator, there is adequate ventilation in the room. And also you're supposed to clean the oxygen concentrator itself, that is the outside as well as the inside, from time to time. So to clean the outside, you should use a damp cloth. And also you can clean the air vent using a cotton swab, a cotton swab to clean the vents. And also to clean after cleaning the outside, you should let it air dry. You're not supposed to dry it on the sun, just so you know. And also to clean the inside, you can blow the inside using an air compressor or a blower itself. But then still more, so in some cases you still have like extra dust remaining inside the oxygen concentrator. So you can use a damp cloth, minding not to use the damp cloth on the control board and areas that like have electricity or electric wires on them. So this sums up our topic of today, and over to you, Maui.
Thank you very much, Francis, for that explanation. I hope it was detailed enough. So if you have any questions from the audience or comments, please raise your hand and then Francis will address them. I see we have a hand from Noel. Is that an old hand? All right, if we do not have any questions on the presentation that Francis just gave, we'll move on to our next question. So the next question says, I'm a biomedical engineer at a private hospital. I received an oxygen concentrator from the theater with a complaint that when switched on, there was no oxygen flowing out of the concentrator, though the compressor was running, and that it goes off automatically after some time. When I turned on the concentrator, I heard the sound of pressurized gas inside the concentrator. When I opened the concentrator, I found all tubes intact with no kinks, but the air was being released through the relief valve. I then disconnected the tubes that go to the seatbed outlets, and there was no air flowing out of the seatbeds. But when I removed the pipe from the outlet of the compressor, air was being released through the exhaust port instead of the relief valve. What could be the cause of this problem? I'll ask Sharon to please take this one up.
Thank you, Maui. Okay, so a lack of airflow at the outlet of oxygen concentrator is mostly caused by blockage in the air passages, which can be due to kinked tubes, blocked seatbeds, and blocked or faulty valves. The valves can be one valve that ensures unidirectional flow of air, solenoid valves that ensure air flows into one of the seatbeds, and the lead valves inside the compressor that allows air to be drawn in or flow out of the compressor. The solenoid valve becomes malfunctional if it is not receiving electrical signal from the control board. Its coils are bent due to power overload, or when dust or other particles get access to the inside, making the movement of the plunger difficult. So with the information given by the technician, it shows that the problem was with the solenoid valve, as air was flowing out of the compressor when the valve was disconnected, but there was no air flowing out of the valves. To confirm if the valve is not working, turn on the concentrator and listen if there is creaking sound from the valve. If you can hear the sound, then the valves are receiving the signal from the control board. that it is failing to open due to either a stack plunger or blockage by dust or other particles. If there is no sound head, then it may not be receiving the operating voltage. So measuring if there's voltage across the two pins of the valves. If you connect a multimeter across the solenoid, it has to show the voltage at some point when the cycle is on that valve. If no voltage is measured, then it can be a problem with the electrical connections or the control board. So you have to replace the valve if necessary, or the electrical connections if they are faulty, or you have to replace the board if it's necessary. Thank you.
Thank you very much, Sharon, for that explanation. So I see we have another poll here. Amapri, if you would please launch that one up.
Yes, so our poll question is, have you ever replaced a valve block because it had a stuck plunger or a burnt coil? All right, it seems like this one is very 50-50. And also just a quick apology, the graphic was the wrong graphic for the question that Sharon just answered, in case anyone was a little confused.
Yeah. All right, thank you very much, Amapri. So reaching this far, this brings us to the end of our concentrator talk today, and would like to thank you all for joining us on this week's concentrator talk. We have an announcement, so Amapri will make that announcement.
Yes, thanks, Maui. So I hope everyone has been receiving our emails and the invitation for their calendars. So in that case, you may have already heard on March 17th, which is 2 concentrator talks from now, we will be hosting a special session. This is a part of the monthly change that we'll be doing. So once a month, we will host an oxygen talk, which will be at the same time as the concentrator talk, but it will be a topic that is from some about oxygen, but not a Q&A like we have today on concentrators. So our first talk will actually be a webinar by Peak Scientific, which is a company from Scotland that is going to explain to us some of the basics on a PSA plant, and they will be focusing on component repair for PSA plants and some of the troubleshooting some of the troubleshooting points that need to be relevant for all PSA plants. So this will be on March 17th. We will send a bunch of reminders before that, but if you have questions specific to PSA plants or are working on PSA plants right now and you want to send anything in advance, please feel free to do that. Otherwise, our first oxygen talk will be on PSA plant troubleshooting on March 17th, and we welcome you all to attend. Any comments or questions on that? We are very excited to bring you something a little bit new and different from just the concentrator talks that we've been doing. Okay, then my next question is, we spent a little bit of time going over humidification today. There were some questions. I just want to do a quick poll to see if somebody would like, or if you guys would like an educational session on humidification. So this would be the same, 10-minute topics that we're doing. And I've just launched a poll here with that question. So if we do want to learn more about humidification, we can schedule that in as well. Okay, so far it looks like a resounding yes. I have no votes for no. So we will put that into the schedule probably after the oxygen talk. Maui, do you want to wrap it up and just remind everyone about their email addresses?
Yeah, sure. Thanks, Amapri. So just a reminder, I've seen a couple of people dropping their emails. We thank you very much for that. So those that haven't given us their emails yet, drop it in the chat, and then we'll add you to our mailing list so that we keep sending you updates and reminders about the Concentrator Talk. Also, we have a YouTube channel where all the recorded, we have recordings of our previous sessions. So all of them are uploaded to our YouTube channel, so you can check them out from there. Or if you missed one of the concentrator talks, you can catch it from our YouTube channel. So reaching this far, I would like to thank everyone for joining us this week, and we'll see you in our next concentrator talk. Have a great week.
And we will keep the chat open for a few minutes in case anyone has any questions or comments. Thank you all for joining.
Thank you very much, Amarpreet and Mavi, for today's wonderful oxygen talk. And thank you very much for having us today's talks. And we'll be updating our work in Nepal in our next oxygen talk. Thank you very much.
Thanks, Bikash and team, for joining.